Hello, student. You are watching my YouTube channel. On this YouTube channel, I am uploading the chemical engineering related video. That video helps for undergraduate chemical engineering student to get the knowledge about the chemical engineering subject. Here we learn about the chemical process technology. In that subject, there is a third unit. It is known as the nitrogen industry. Myself, Tejmal Mahale, I am delivering the lecture on the Hello student, myself Tejmal Mahale. You are watching my YouTube channel. On this YouTube channel, I am uploading the chemical engineering and technology videos. That videos helps to chemical engineering aspirant to get more knowledge in simple and easiest way. In this video, we learn about the chemical process technology, which is the second year chemical engineering subject. In that subject, there is a third unit that is known as the nitrogen industry. Before starting the lecture, please subscribe my YouTube channel and hit the bell icon so you can get the notification whenever I uploaded the new video on this YouTube channel. Now, our topic is nitrogen industry. Before starting the nitrogen industry, we will get the knowledge about the nitrogen. In this slide, you see the picture of the nature, and we know that the most of the animals, human beings and plant, they are the consuming the air. Means whenever we done the respiration, that respiration we intake the air, and that air containing the 79% of nitrogen and remaining is the oxygen and different gases. The nitrogen is the most important thing which are required for the human beings as well as plant and organic material. For that, in details, we studied about the nitrogen. Nitrogen is an inert gas. It is odorless, colorless, and does not sustain life. Through its important for the plant growth and is key additives in the fertilizer. We know that the more about the nitrogen, there is a fertilizer industry in the chemical industry where you use more nitrogen, and that nitrogen which is converted into the ammonia and nitric acid and many more products. It is used range of the beyond the gardening sphere. The nitrogen usually appear in the liquid or gas form, and whenever it is required, then we can transfer into the solid form. The liquid nitrogen is used as a refrigerant, which able to rapidly freeze the food and subject in the medical research as well as the reproductive technology, which is under the biotechnology. For the purpose of the compressed gas air system, we stick with the discussing with the nitrogen gas. Now, the nitrogen is the widely used to the fact that it's not react with the exposed to the other gas. Hence, the nitrogen is called as a inert gas. unlike oxygen which is extremely reactive, means which comparative with the oxygen which is highly reactive and extremely taking in the part in the reaction. Due to its chemical composition, nitrogen atom needs more energy to be react with the other substance or broken into another form. The oxygen molecule, on the other hand, they are the easily break apart while making the gas much more reactive. The nitrogen gas is opposite in nature, providing the non-reactive environment where we require it. Hence, the nitrogen is abundantly used in the chemical engineering for the non-reactive environment, and that can help us to control the chemical reaction. Now, the lack of reactivity of the nitrogen, it is the biggest quality of that element. As the result, gas is used to prevent as slow and fast the oxidation, and where we can use as a nitrogen. The electronic industry present the perfect example of this use as the during of the production of the circuit. Whenever the circuit board which is manufactured from the other small component where we require the slow oxidation, and for that we use the nitrogen gas, and it can help the avoid the corrosion. The slow oxidation is the also stranger to the food and beverage industry. We know that the food industry and beverage industry where the oxidation is carried out, then the food as well as some beverage material gets spoiled. Hence, we use the nitrogen, where it is used as a replace the air in the order better to preserve the end product. Explosion and fire where the nitrogen is used, and that is known as the fast oxidation process, since they are fueled by the oxygen and removing the oxygen from the vessel. The nitrogen accident can be occur. There are the two type of nitrogen generator. One is the membrane nitrogen generator, and another is the PCA, that is pressure swing nitrogen generator, which is allow about 99.9% pure nitrogen can be achieved. Now, this is the information regarding the nitrogen. After that, nitrogen which is used in the chemical industry, that is the ammonia manufacturing process. Ammonia is the nitrogenous compound which can be manufacturing by the nitrogen and the hydrogen, which has a formula that is NH3, and this is the colorless as well as the characteristic pungent smell which is known as the ammonia, that is the smell like as a rotten egg. The ammonia contribute the significant to the nutritional needs of the organism by the serving of the food and fertilizer. The ammonia either directly or indirectly a building block for the synthesize many fertilizer, pharmaceutical, and is used in the many commercial cleaning product. although wide use the ammonia in the both caustic as well as hazardous. The ammonia is used commercially called as anhydrous ammonia, and that term emphasizes the absence of water in the material, because NH3 is boiled at minus 33.44 degrees Celsius at the pressure of 1 atmosphere. The liquid must be stored under the high pressure at low temperature, that is known as the household ammonia, or ammonium hydroxide is the solution of NH3 in the density with 26 degree, that is known as the 15.5 degrees Celsius. The typical high concentration commercial product, the household ammonia ranges is in the concentration from the 5 to 10 weight percent of ammonia. Now, before starting the production of the ammonia, we know the physical property and chemical property of ammonia. Ammonia has a flammable limit around 16 to 20% by volume in the air, as well as 15 to 79% in the oxygen. Ammonia air mixture is the 650 degrees Celsius. The mixture can be exploded if ignited. The ammonia is readily soluble in the water. A large amount of heat, that is around 520 kilocalorie, is produced when the dissolution of the 1 kg of ammonia gas occurs. The physical property in that molecular weight, that is 17.03, boiling point in degrees Celsius, that is minus 33.35 degrees Celsius, freezing point in degrees Celsius, that is minus 77.7. Density of ammonia when the weight percent is in the weight percentage form, there is 18, 16, 32, 50, 75 and 100. The density with respect to 0.970 density, whenever the weight percent getting increases, the density would reduce. Now, we will move towards the production of the ammonia. This is the flow sheet which is used for the manufacturing of the ammonia, and that manufacturing of ammonia which is done by the Haber process. Ammonia is the produce in the process known as the Haber process, in which the nitrogen, hydrogen react in the presence of the ion catalyst to form ammonia. The hydrogen formed by the reacting natural gas and steam at high temperature, and the nitrogen is supplied from the air. The other gases such as water and carbon dioxide, which are removed from the gas stream, and the nitrogen and hydrogen which are passed over on the ion catalyst at a high temperature and pressure to form ammonia. This diagram is the systematically process which is used for the production of the ammonia. In the production of the ammonia, there are the 6-step process. The steps we will see in the next slide. There is a first step where the hydrogen production takes place. The hydrogen is produced by the reaction of the methane with the water. However, before this can be carried out, all sulfurous compounds must be removed from the natural gas to prevent the catalyst poisoning. These are the removed by the heating gas up to the 400 degrees Celsius and the reacting with the zinc oxide. the reaction which is first reaction, which is zinc oxide, which is react with the H2S, and where the zinc sulphate is formed and water is obtained. Following this, the gas is sent to the primary reformer, which is shown in the previous diagram, for the steam reforming, where the superheated steam is fed into the reformer with the methane, and the gas mixture is heated by the natural gas, purged gas up to the 770 degrees Celsius in the presence of the nickel catalyst. At this temperature, the following equilibrium reaction are the derived in the right to converting the methane into the hydrogen and the carbon dioxide and small quantity of carbon monoxide which is formed, where the second, third and fourth reaction which is carried out, where the methane is reacted with the water to obtain the hydrogen as well as carbon monoxide, where the methane which is reacted with the large quantity of water, then we obtain the hydrogen and carbon dioxide, where the carbon dioxide carbon monoxide and water which is reacted to get the hydrogen as well as carbon dioxide. This is the gas mixture which is known as the synthesis gas. Now the next that is the secondary reformer, which is next process, where the second step which is carried out. The second step, it is known as the addition of the nitrogen. The synthesis gas which is cooled to 735 degrees Celsius, then the flow into the secondary reformer, where it is mixed with the calculated amount of air and where the nitrogen addition is takes place. This is the very highly exothermic reaction between the oxygen and the methane, produce more hydrogen and some reaction which are the below. The reaction are the carbon monoxide plus water give the carbon dioxide plus hydrogen. When the oxygen which is reacted with the methane, we obtain the carbon monoxide as well as hydrogen atom. Oxygen which is reacted with the methane, then we obtain the carbon dioxide with hydrogen. When the oxygen react with the methane, we obtain H2O as well as carbon dioxide. In the addition of the necessary nitrogen which is added into the secondary reformer, as the catalyst is that used to form the ammonia, which is catalyst as a pure ion, where ion, water, carbon monoxide and carbon dioxide must be removed from the gas stream to prevent the oxidation of the ion, and this is carried out in the next third step. The third step, which is production of the ammonia, where the removal of the carbon monoxide taken place. Here the carbon monoxide is converted into the carbon dioxide, and this reaction known as the water gas shift reaction, where the carbon monoxide which is reacted with the water and we obtain the carbon dioxide plus hydrogen. This is the achieved into the two step. Firstly, the gas stream is passed through the chromium peroxide catalyst that is known as the Cr/Fe thrice O4 at the 360 degrees Celsius, and which is then over the copper, zinc oxide and chromium catalyst at around 210 degrees Celsius. The same reaction which is occur on the both step, that is the step number 3 and step number 2 to maximize the conversion reaction. After that, there is a next step that is known as the water removal. The gas mixture, which is further cooled up to the 40 degrees Celsius. At this temperature, water which is condensate and out from the removal side. After that, there is a fifth stage where the removal of the carbon oxide. The gas are the pump through the counter current where the carbon dioxide is the highly soluble and more than 99% in the pure of the carbon dioxide in the mixture dissolve in it, and the remaining carbon dioxide which is converted into the methane by using the nickel catalyst at around 325 degrees Celsius, where the following reaction is taken place, where the carbon monoxide reacted with the hydrogen, we obtain the methane gas as well as water, and carbon dioxide which is reacted with the methane, then reacted with the hydrogen, we obtain the methane as well as water. The water which is produced in this reaction, which is removed by the condensation at 40 degrees Celsius. As we know that the carbon dioxide is stripped from the secondary reformer, which is used as a urea manufacturing process, and that is the another process where the urea can be manufactured. After that, there is a sixth step, means the last part of the flow diagram, where the synthesis of ammonia is taken place, that is known as the sixth step. The gas mixture is now cooled, compressed and fed to the ammonia synthesis loop. A mixture of the ammonia and unreacted gases which are readily be the around of the loop are the mix and the coming in the gas stream, which is cooled up to the 50 which is up to the 5 degrees Celsius. The ammonia present is the removed and unreacted gases are heated up to the 400 degrees Celsius at the presence of the 330 bar and pass over the ion catalyst. The under condition of the 26% of the hydrogen and nitrogen, which is converted into the ammonia. The outlet gas from the ammonia converter, which is cooled from the 220 degrees Celsius to 30 degrees Celsius, and this cooling process which is done by the condense more half of the ammonia, which is then separate out, and the remaining gas is the mixture with more cooled compressed as a incoming gases. The reaction occurring in the ammonia converter is nitrogen, which is reacted to the hydrogen, and we obtain the NH3, and that is known as the ammonia. The ammonia, which is rapidly decompressed to the 24 bar, and at this pressure the impurities such as methane, hydrogen that are converted into the gas phase, and that gas mixture above the liquid ammonia, which can be separated from the ammonia and is removed and sent to the ammonia recovery unit. This is the absorber stripper system using the water solvent. The remaining gas, that is known as the purge gas is used as a fuel for the heating in the primary reformer, and the pure ammonia remains in the mix with the pure ammonia from the initial, and the condensation above the and the ready to use in the urea production, and it is also storage for the direct sale. This is the completion of the ammonia manufacturing process, and thank you so much. Before ending the today's session, I am requesting, if you like the video, you can subscribe my channel and hit the bell icon. Thank you so much.